Hello, everyone. Good morning, afternoon, and evening. Dear authors and invited guests, welcome to Technical Session 6D. I am Pranjal Banage, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Congress on Information and Communication Technology, ICICT 2026, in London, UK. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in London, UK, and the virtual event is being held through Zoom from 25th to 27th February 2026. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentations and 3 minutes for questions and answers. In 10 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any queries or updates, then you can write it to me or to my co host in the chat box. Now, before we start the session, I would like to introduce you all to the chair of this session, Dr. Sachin Jain. He is an associate professor at Oklahoma State University, United States, with over 19 years of teaching and research experience in computer science and engineering. He has published more than 20 research papers in international journals and conferences. His research interests include wireless sensor networks, artificial intelligence, Internet of Things, blockchain technology, machine learning, pattern recognition, and digital image processing. I would ask Doctor to come and give his closing remarks.
A very good afternoon. Can you hear me?
Yes, sir, you're audible.
Thank you, Pranjal. Ladies and gentlemen, dear participants and guests, it is my great pleasure and privilege to welcome you all to the 12th International Congress on Information and Communication Technology 2026. As the session chair for this session, I'm pleased to see a diverse, talented, and accomplished group of people gathering together, representing backgrounds and expertise from around the world. In the next 1.5 hours, we will engage with various topics across discipline and contents, all united by the common goal of advancing knowledge and innovation. I encourage everyone to make the most of this opportunity, connect with your fellow colleagues, attendees, actively participate in the discussion, and dive into the innovation ideas. Let us embark on this journey together. I am excited for the opportunity to engage in enriching discussions, gain value insight, build strong connections, and uncover new discoveries. Thank you and all the best. Thank you.
Thank you so much, sir. Moving forward, I would like to introduce our next session chair, Dr. Sangeeta Kurundkar. She is an associate professor in the Department of Electronics and Telecommunication Engineering at Vishwakarma Institute of Technology, Pune. She brings 37 years of academic experience to her role. Specializing in wireless communication, Dr. Kurundkar has been a valued member of the Institute since 2002, contributing extensively to teaching and research in her field. I would now like to ask her to give her opening remarks.
Actually, I'm also very much excited for attending and listening to all the participants. So let us, I think, start with the session. And after listening to all of this, I would like to then give the concluding remarks. Okay. So you can go
Thank
ahead
you,
with the.
ma'am. Yes. Moving forward, I would like to call upon our first presenter, Vinjay Singhe, to present her paper on a critical review of cognitive complexity metrics and tools, gaps and opportunities for ERP systems. You may proceed with your presentation by sharing your PPT.
Hello everyone. I hope you can hear me properly.
Yes, you're audible.
Okay. Let me share my screen. Can you visible my screen, people?
Yes, it's visible.
Yeah. Good evening, everyone. I'm Sandhuni Vijay Singh. I'm representing SLIIT Sri Lanka. Today, I'll be presenting my research title, a critical review of cognitive complexity metrics and tools. I have identified few gaps and opportunities for the ERP system. This study mainly focuses on evaluating the existing cognitive complexity measurements and approaches and examining the suitability for the enterprise resource planning environments. So let's move on. So software complexity is widely recognized important factor that affects how developers understand and maintains the software system. It influences some program completion, maintenance effort throughout the software life cycles, and ultimately an overall quality of the sustainability of the software. As software systems continue to grow and size become more functionality and integrated, maturity and complexity become increasingly important. That's why I am focusing on decide what would be the next software complexity metrics. These measurements help organization identify defect-prone components to support refactoring decisions and better management and maintenance effort, and also operational cost. However, most traditional complexity metrics mainly focus on structural characteristics of the code, and it's provide limited insight and actual cognitive effort required to developers to understand complex systems. So let's begin this research, move forward. Early in the research, software complexity mainly focused on structural analysis of programs. As well-known example is cylomatic complexity. Cylomatic complexity measures the number of independent execution paths in the program. As simple to, as simply we discussed, it helps estimate how complex the program control flow is. And another commonly used approach is Halston software science. It estimates development effort based on the operators and operands used in the code. It only used in the operators and operands used in the or in the codes, not others. However, as even through these metrics mathematically well defined and well used in previously. So, overcome these limitational structural metrics, cognitive complexity metrics are introduced. That's why we discuss about today world's cognitive complexity metrics. The main idea behind in the cognitive complexity metrics is the mental effort required by developers when understanding the program rather than focusing on the program structure line by codes. Rather than structuring line by codes, we are identify the mental effort required by developers. And these approach assign cognitive weight to weight control structure within the software system. The they are also they are also consider the factors that software hardens and understand. Likewise, nesting deep, coupling, inheritance, and recursion also. Finally, special regressions. So overall, software complexity assessment shift the more developer-centered perspectives. That's why we are discussing about in today's world software complexity metrics. So make the complexity measurement more practical, and automated tools are developed to the support software complexity analysis. In recent years, so new advancement of these areas based on the AI-based approaches. Likewise, these may include machine learning-based approaches and graph-based approaches, likewise, also transfer-based approaches to analyze the pattern of source codes. However, many AI-based approaches operates black box systems, not in the other sides.
Which would be Adrian Sajula. I would now ask you to present your paper on ORIS, an LLM-driven framework for structured mental health assessment using mixture of experts and architecture. Please start your presentation by sharing your screen. Adrian?
Good afternoon, miss. Is the screen visible?
Yes, it's visible. You may proceed.
Okay. So, good afternoon, everyone. I'm Adrian Sahulga from the Philippines, and today I'll be presenting our team's work titled ORIS, AI for Structured Mental Health Assessment. ORIS is an LLM-driven framework designed to bridge the mental health treatment gap through a retrieval-augmented, safety-aware conversational assessor. We built this system on the Llama 4 Scout model, which utilizes a mixture of experts architecture. This specific architecture is crucial because it enables efficient parameter utilization while maintaining high-quality language generation, allowing for scalable deployment without compromising the contextual coherence of the conversation. We combine this with a retrieval augmented generation or RAG pipeline to adapt 14 validated clinical questionnaires across a structured interaction. So, before diving into the system architecture, let's look at the problem we're addressing. Mental health conditions remain widespread, yet severely undertreated due to stigma, high costs, and a shortage of clinicians. While traditional talk therapy is still the efficacy benchmark, many individuals delay seeking care until their impairment becomes severe. Our goal with ORIS is not to replace human therapists or medicalize everyday well being. Instead, we are exploring a digital assistant that acts as a preventive psychiatry prototype, an empathetic, low friction first touchpoint that maintains strict clinical structure. Recent work shows that large language models can deliver highly empathetic, context aware support. However, applying LLMs in healthcare is constrained by multiple factors such as severe privacy issues, hallucination risks, and variations in safety alignment. Recent systems have tried different approaches. Some fine tune models on clinical records, while others replace rigid dialogue trees with instruction driven flows. For ORIS, we built on Llama 4 Scout specifically because it's a mixture of experts design, which includes robust long context support. This extended context window is absolutely essential for maintaining conversational endurance and tracking complex psychological cues over a long screening session. To keep the LLM clinically grounded, ORIS employs a retrieval augmented generation pipeline. When a user speaks, we generate text embeddings using the sentence transformers all mini LM L6v2 model, producing 128 dimensional vectors optimized for semantic similarity. These are then persistently stored in ChromaDB, where we use cosine similarity to fetch the top 5 most relevant clinical items per query. To maintain context, each query is actually a composite input consisting of the user's last 3 conversational turns, combined with an LLM-generated summary of their concerns. Furthermore, we use dual embeddings for every questionnaire item, one representing the formal clinical phrasing, and another representing colloquial semantic hooks to improve recall when users use everyday language. The retrieval system pulls from a highly curated database. ORIS integrates 14 validated clinical questionnaires, comprising exactly 178 individual items in total. This covers domains such as depression, anxiety, PTSD, burnout, and eating disorders, to name a few. We programmatically extracted the scoring rules, reverse scoring flags, and severity thresholds for all 178 items. For example, classifications strictly follow published cutoffs, where PHQ-9, for example, severity ranges from minimal to severe. Because safety is our highest priority, items associated with acute risks such as suicidal ideation are explicitly marked with an is critical flag. If triggered, this flag forcibly routes the system to predefined rule-based safety handling pathways. To make this database scalable, we defined a standardized JSON schema, enforcing required fields like semantic hooks, scoring logic, and diagnostic domains. We also implemented a semantic compression strategy, representing each clinical item by just 3 to 5 word semantic units to capture its core diagnostic intent. Combine this with metadata minification, this approach achieved an average 73% reduction in dataset size, compressing the full 178 item corpus from near 300 kilobytes down to just 80. All of these records are stored in JSON lines format to facilitate streaming ingestion, and schema compliance is strictly enforced at load time using JSON schema validation. This brings us to the interaction flow, which follows 3 phases: report, screening, and snapshot. The system state is maintained using an assessment state type dictionary, which meticulously tracks message history, active scales, extracted clinical data, confidence scores, and crisis flags. During the screening loop, the pipeline detects domain overlap. For instance, if sleep issues trigger both the GAD-7 and the insomnia severity index, the system resolves this by injecting discriminatory prompts. The loop continues extracting responses with confidence scoring, asking for clarification if outputs are low confidence, and eventually generating a SOP formatted clinical summary during the snapshot phase. To measure our success, we utilize the Esro hybrid evaluation framework, which blends automated metrics with LLM-based human proxy assessment. The automated scoring accounts for 70% of the total score and looks at semantic similarity and topic alignment to compute a response relevance score, or RRS. It also calculates a response quality score based on linguistic complexity and historical consistency. The remaining 30% relies on LLM-based human proxy evaluation using Gemini 2.5 Flash. This proxy evaluates empathy at 40%, weight, helpfulness at 30%, safety compliance at 20%, and overall quality at 10%. Our evaluation results highlight a fascinating divergence between automated similarity and human judgment. The automated evaluation resulted in a mean performance of 0.71, achieving high quality scores of 0.89 but lower relevant scores of just 0.53. However, human evaluation yielded a much higher performance score of 0.88. Specifically, the agent performed exceptionally well in crisis safety scenarios, achieving a perfect human evaluation score of 1 for safety and a 0.88 for empathy. This suggests that automated metrics penalize the system from deviating from strict system reference texts, entirely missing the fact that human experts heavily value the practical inclusion of safety resources and the honoring of user boundaries. So, in summary, Oris achieved a final weighted performance of 0.76, demonstrating a solid balance between technical linguistic precision and practical clinical utility. However, we do recognize our limitations. All development and evaluation were all conducted locally, meaning our retrieval performance was constrained by local hardware, and we have not yet characterized end-to-end latency benchmarks or operational costs for production environments. Moving forward, our immediate next steps include domain-specific fine-tuning, developing more clinically grounded automated metrics, and pursuing clinical validation under appropriate ethics oversight before exploring broader user testing. So that's all for the presentation. Thank you all. And I would now like to open the floor to any questions.
Yes, anybody?
Do you have any questions for him?
Thank you, Adrian, for the presentation. I have few questions. Can you hear me?
I can hear you, sir.
Okay. So my first question is, what resources are used in the RAG knowledge base?
So these resources, sir, are like standardized clinical questionnaires which we sourced online, but we validated that we validated to be like the standard for these like different domains. I believe my co-authors can also support this fact, sir. They are also here.
Okay. Why is the automated relevance lower than the expert ratings in your system?
We believe this to be the case since that part of the like evaluation metrics checked mainly for like semantic similarity. So it wasn't able to like determine or like properly evaluate the lines based on like the context itself, and instead checked for exact word to word similarity. I believe that to be the case, sir.
Okay. One final question. What does the system do if the user says something indicating self-harm or suicidal risk, like in real-time scenario? I think you discussed in your presentation. Just I want to like reconfirm that. What will be the outcome of your system?
Typically, what the system would do, sir, would it would basically stop all general like assessment procedures and would proceed with um, giving the user first and foremost hotline resources specifically for their like um, location, depending on their location, the right numbers, suicidal hotlines, and such, in order to prevent any possible or any further suicidal ideation that would um, be a tragic loss for everyone.
Okay. Thank you.
Yes, I also have two questions. First one is like, what is the failure case scenario you are most concerned about?
If possible, could I have the question repeated? I'm sorry, I think I'm
So
a bit.
what is the failure case scenario you are most concerned about in whole of your experimentations? Like,
So I guess one failure scenario that we're really worried about is if users end up using this as an actual like diagnostic tool. We would like to emphasize that this tool is mainly for psychiatric screening. We still do believe that a human touch is required for this kind of scenario. So they must use this tool only for screening and to help basically reduce or point someone to the right direction before they could actually start using money for therapists, which could get expensive. One other possible issue that we have right now is, or one possible failure scenario we have right now is, we haven't fully tested this in real world clinical situations or scenarios. So there might be situations we haven't taken into account of that we would have to employ the help of actual or more clinicians and more testing in order to safely and securely get out into the world.
okay. So have you tested your system, like how scalable it is across cultures and languages?
Currently, we have not yet done so. However, as one of our future works or possible improvements to the system is testing this out in multiple different languages, different types of models, different types of architectures and such, in order to fully grasp the capabilities and what other improvements we could work or we could give the system.
No. Okay, and the last question, like, what are the theoretical limits of conversational AI in psychiatry? Conversational AI. So theoretical limits, are there any?
To be honest, I really can't say for certain. However, seeing that LLMs are still continuing to grow and its capabilities might not be fully are something that we might not be fully aware of, I'm sorry, but I can't like
Okay,
fully
okay,
determine.
okay. Thank you so much. You can go ahead.
Thank you, thank you.
Thank you so much, Adrian, for your insightful presentation.
Thank you, thank you.
Now, I would like to move forward with our next presenter, Nikita Sabre. I would invite you to present your paper on Cloud Native Threat Intelligence Framework for AI and ML, able detection and mitigation of zero-day attacks. Please share your screen and start with your presentation.
Yes. Is my screen visible? Hello.
Yes, Nikita.
Is my screen visible?
I don't think it is.
Not yet, ma'am.
Not yet.
Just a minute. Am I audible now?
Yes, you're audible. Please continue with your presentation.
Good afternoon, everyone. I am Nikita Savle and I am going to present on the topic today, that is Cloud Native Threat Intelligence Framework for AI and ML enabled detection and mitigation of zero-day attacks. My paper ID is 817 and I am a research scholar from Bhagwant University, Ajmer. So, cloud native infrastructure has significantly expanded digital attack surfaces. Zero attacks are especially dangerous because they exploit the vulnerabilities, which means traditional signature based intrusion detection systems cannot detect them. Existing systems are reactive, rigid, and often produce high false positives. Our motivation came from the three critical limitations, that is, firstly is the high false alarm rates, secondly poor adaptability to new attack variants, and third lack of explainability in the AI based detection systems. So I wanted a system that detects, adapts, mitigates, and explains all within a single unified architecture. The research addresses four key questions: that how to detect the unknown attacks, how do we adapt them without retraining the system, how do we provide the interpretability reasoning, and how do we optimize the mitigation decisions in the real time. The objective was to build a cloud native unified framework that achieves the high detection accuracy, reduces false alarms, and adapts quickly to the emerging threats, provides explainable decisions, and optimizes containment strategies. So, this zero-day attacks give a huge damage to the system. For that, it is very important to detect as well as mitigate them in every way they are happening. The framework consists of the five key modules, that is CRGNH, NIEIN, QIVACL, HBRM, and ECMLF. So these are the five models that we have used in the framework for solving all these issues related to this. And this is the proposed framework flow, which shows all the five modules, and this is the complete pipeline. Here we start with the system calls, network flows, logs, and malware binaries. All these are given to the CRGNH, which extracts the contextual dependencies captures multi-hop contextual relationships in the system called graphs. Unlike shallow models, it preserves the long-range dependencies using residual graph learning. The significant improvement of anomaly contextualization and detection accuracy is there. Then next is the NIEIN model, which uses the incremental encoder, immune evolutionary module, and the knowledge update memory. This is inspired from the immune systems. Instead of retraining the system from the scratch, it evolves to recognize the new threats through mutation selection, new threats. This reduces adaptation time to nearly the one third compared to the baseline models which were used previously. Next is the QIVAE-CL encoder, which uses the contrastive learning module with it for the discriminative latent embeddings. And this reduces the false positives by clearly separating benign anomalies from the malicious behavior. And then parallelly works the HBRMN and ECMLF. HBRM was the uses the hierarchical reinforcement learning. It ranks mitigation actions based on the system damage, latency, and availability. This ensures optimized containment with minimal operation disruptions. Then ECMLF introduces the casual meta learning. It builds the cyclic causal graphs linking events to attack outcomes. Also generalizes to unseen zero-day families and improves interability scores significantly. And finally, the anomaly and mitigation decision is taken through this both HBRMN and ECMLF modules. We have used the NVIDIA A100 GPUs and 512 GB RAM for the test for the implementing this 5 modules, and this is the results we have attained. The first table describes that the system call graphs in our proposed model gives the detection accuracy of 97.6%, which is almost 98% we can consider. To the if we compare these to the baseline models which are previously used in other researches, they gave the accuracy of maximum 91.8% on system call graphs. We are using different parameters for testing and detecting the threats that are happening on the zero-day attacks that are happening on the cloud. Then second table is the positive rate percentage across various data sets. So the false positive rate also is 2.1%. Lowest is the lowest the false positive rate, better is the system. So our system gives the 2.1% of accuracy. Then third table shows the adaptation time to emerging attacks in seconds. Whatever the new attacks are happening on the system, that attacks are adapted by the system, and the uh, uh, frequency of the adaptation is 14.2. So this means that if the attacks are happening, it gives more it takes a less time to adapt that and stop that attack. So comparing to the other methods or the other models, our system is 3 times faster. Then fourth table is about the mitigation efficiency, that is the containment time reduction percentage. So in our system, the attack stopped 32% faster as compared to the other models. And this is the fifth table, which shows the generalization to unseen attack families. The unseen attacks are those which have never happened before, and those attacks are adapted by our system, and that attacks are also mitigated, detected and mitigated by our system, and it gives the accuracy of 93.5%, which is very, very high as compared to the other models. And the last table is the explainability and interpretability score, which is from this in the between the scale of 0 to 1. So 0 means the perfect explanation of the model, and 1 means perfect explanation, and 0 means no explanation. So our model gives the 0.87 score, which means it gives a very good clarity of that threat. So overall, our system is adaptable, accurate, fast, explainable, and adaptive to the environment or the new incoming threats. So overall, all the tables collectively shows that the false positive rate are reduced, the speed is adapted, mitigation efficiency is increased, and the interpretability is also increased. Through the combination of all these 5 models, we have increased the detection and mitigation rate of the zero-day attacks, which gives a huge loss to the system if they occur. So this model was trained for detecting attacks with 97.6% accuracy on system call graphs, 96.8% on network traffic flows, which is much better than the third method, that is the paper number 3 in the references, which has used that method, and others from reference number 8 and 15. So, extracting the other contextual dependency sets with CRGNH improves the performance. And collectively, all the parameters give the efficient system for the threat detection and mitigation systems. These are all the references that I have used. And thank you.
Thank you, Nikita. I would like to ask the session chair if she or he has some questions for her.
Yeah.
Okay. So my first question is, you stated about 97% detection. So your paper, it reports 97% detection improvement. Okay.
Yes.
So relative to which baseline? Actually, you mentioned also the baseline, general.
Yeah, that the references which I have taken, they have not mentioned the exact algorithm or the exact methodology they have used, but the parameters they have used for testing are similar to the parameters we have used, and accuracy they have achieved in their research. We have compared them with our results.
Okay. And the second question is like, what is the framework's latency under this live attack conditions?
Yeah. Under the live attack condition, also the system works in the same way as it is working now, as the results it is giving now.
So latency.
Latency is also good.
So okay, so exact percentage or value, or you're not aware about that. Okay.
Yeah.
And the last question is like, how transferable is your framework across industries like finance or healthcare, defense? So is it transferable?
Yes, it is transferable, but right now we have worked on this data set which is related to the airport system. So we have worked on that data set, but yes, it is transferable.
Okay. Thank you.
Thank you, ma'am.
Hi, Nikita. Can you
Yes,
hear
sir.
me?
Yes, sir.
My first question is, how does your framework identify the attacks that is not seen during the training?
Sir, by using the second technique, that is the HRBMN model, it uh, automatically detects the threats, and it gets the system to learn the new attacks are happening, and the system automatically retrains itself to that upcoming attack, new incoming attack, and it further it detects the abnormalities whatever are happening in that attack, and it mitigates it according to that.
And how your system reduces the false alarms compared to IDS system if you are compared?
Yeah, it for the false alarms, it is using the nature inspired enforcement learning method, which I have mentioned, that is NIEIN. It is a self-learning model, so it reduces the false alarms. And also we are using the quantum-inspired variational encoder learning, so it is also helping it.
Okay, thank you.
Okay. Thank you, sir.
Thank you so much, Nikita, for that impactful presentation.
Thank you, ma'am.
Yes. Now, I would like to move forward with our next participant, Mohammad Sabiri, and I would like him to present his paper on quantum and LCD codes from the concentric codes derived from ring S7. Please share your screen and start with your presentation.
Yeah. My screen is visible?
Yes, your screen is visible.
Yeah, I am Professor Sabir Mohammed of Faculty of Science and Technology, Rashidia University, Moulay Ismail, Morocco. In this work, we talk about quantum and LCD codes from the concentric codes derived from the ring S7. Quantum error correction codes has a decisive effect in the development of quantum computing. They are essential for mitigating errors caused by noise and imperfection in quantum systems. The foundation of quantum error correction code can be traced back to classical error correction code, which was developed in the 20th century by researchers such as Claude Shannon. These codes allow for the correction of errors that occur during data transmission or storage in classical computer. Shor's work was a crucial step in the field of quantum computing. His work was crucial because it demonstrates how quantum information could be protected against errors. The CSS construction is one of the most interesting code constructions shown in the literature. This construction begins with two classical linear codes and they are continuing linear codes. These classical codes are selected based on their properties suitable for error correction. By using this construction, it's possible to derive families of quantum error correction code with various parameters, providing exhaustivity and exhaustivity in quantum information. The rank under consideration S7 is of finite non-Shannon rank. FPM is a finite field of coordinated PM. The rank S7 has 7 non-zero independent elements: variable 1, variable 2, variable 3, variable 4, variable 5, variable 6, and variable 7. As codes of over finite rank, or linear code C of Langet and over S7 is an S7 model of S7n. In the same way, a linear code C over S7 is theta constant cyclic code if theta I and minus 1, I and minus t in C1, I0, I1, I and minus 1 in C. In order to give linking between codes over the rank S7 and the codes over the finite field FPM, we define the gray map Phi7 as below. This map can extend it to S7n in the following way. M is an invertible matrix of order 7. This map preserving distance. For code C of Langet and over S7, we define Ci as follows. Ci are linear codes of Langet and over FPM, and we prove that every linear code C over S7 is a direct sum of variable ICI. Ci are the components codes for the code C. And we prove that if C is a linear code of Langet and over S7, then its orthogonal is a linear code of Langet and over S7 of components orthogonal of Ci. And if we choose M such that M MT equal to mi I 7. I7 is the inductive matrix over FPM. We prove that the orthogonal of phi7 of C is exactly phi7 of orthogonal of C. And if theta is an element of F7, then theta is unity over F7 if and only if theta I are unity of FPM. And if C or theta constant cyclic code, then we prove that C is constant, theta constant cyclic code if and only if Ci are theta I constant cyclic code. For a theta constant cyclic codes over the rank S7, then there exists a polynomial g of x. G of x divides x and minus theta, and C is generated by g of x, and g of x equal to sum from 1 to 7 of via rho I gi of x. The polynomial gi generated theta I constant cyclic codes Ci respectively. Assume that C or alpha constant cyclic code over the finite field FPM and alpha equal to plus or minus 1, then C contains its dr if and only if we have the following condition. As consequence, for theta constant cyclic code over the rank S7, if theta I equal to plus or minus 1, then C is dr continued code if and only if we have the following conditions. As a result, for a linear code, constant cyclic code of parameters n kd over the rank S7, C such that C is ODR continuing code, then there exists a quantum error correction code over the finite field FPM of parameters 7n to k minus 7nd. For example, S7 constructed from F17 and n equal to 34 for J1 of x equal to J2 of x equal to J3 of x equal to x plus 16, J4 of x equal to J5 of x equal to x plus 4, and J6 of x equal to J7 of x equal to x plus 13, and for the following matrix M over F17, the code C is constant cyclic code, orthogonal of C is included in C, and then there exists a quantum error correction codes over F17 of parameters 238, 224 too. In the following, we talk about the ICICT codes, and by using constant cyclic codes over the rank S7 under some condition, we give a simple method to find ICICT codes. Recall that the ICICT codes were introduced by Missy in 1992 in his paper Linear Codes with Complementary Ideas. We begin by giving some definitions. A linear code C of length n over S7 is an ICICT code if the intersection between the code and its orthogonal is reduced to 0. And if C equal to sum from 1 to 7 of via rho ICI, so C as an ICICT code if and only if so the Ci are the components of the code C. Ci are the linear codes of length n over the finite field FPM. Assume that C is an ICICT code of length n over S7, then phi7 of C is an ICICT code of length 7n over FPM. If C a non-trivial beta constant cyclic code of length n over the finite field FPM such that square of beta is different from 1, then C is an ICICT code. As consequence, if C or theta constant cyclic code such that theta I square is different from 1, then C is an ICICT code over the rank S7. For example, for n equal to 26, FPM equal to F13 and theta equal to 2, gi of x equal to x4 plus 9x squared plus 4. Then The code C is an LCD code. Phi 7 of C is an LCD code over F13 of parameter 182, 154.3. And for gi of x equal to x plus 6 plus 7x4 plus 12x squared plus 5. The code C is an LCD code, and then phi 7 of C is an LCD code over F13 of parameter 180 to 144. There is some example for codes constructed over the finite field F29 F13. We conclude that this CSS code consequences is indeed a similar method in the field of quantum error correction code, and it has been extensively studied and applied in quantum information theory. This construction technique enables the systemic derivation of families of quantum error correction code rather than just a few specific code with predetermined parameters. The aim of this paper is to construct quantum error correction code and LCD codes of length 5n over the finite field FPM. The first code are obtained by using the gray map and the CSS construction. From the continuing code, the second code are made as the gray image of LCD codes of length n over F7. In the future, we look to give other quantum code which have good parameters by using codes not necessarily counting their DR. And I would like to warmly thank the organizer of this conference for its outstanding organization, their professionalism and attention to detail contributed to the success of this event. It was a real pleasure to collaborate with you. And thank you for your attention. Thank you.
Thank you, Mohammed. I would like to ask the session chair if they have any questions for him.
Hi, Mohammed. Can you hear me?
Yeah.
So my first question is, why did you choose the ring S7? What's the reason behind?
But because the ring S7 has seven idempotent elements.
So
Then we can consider this ring as FK7. This has a basis of 7 elements as a vector space as FQ.
So what are the advantages of using the ring S7?
Yeah.
What are the advantages? Like, what's the reason behind? Like, are there any additional advantages of using S7 for the code construct?
Yeah, if you don't S7, then for this we can find a code of length 7n. For this we see the utility of for S7. The S7 has a set non-zero idempotent elements.
Okay. Why are the constant cyclic codes are preferred over the cyclic codes here?
I don't hear your question.
Why are the constant cyclic codes are preferred over cyclic codes? Can you hear me?
If I understand your question, I use constant cyclic codes.
Why it is preferred over the cyclic codes?
I use constant cyclic codes because every constant cyclic is generated by a polynomial, and then we have free codes over the S7, and by degree image we have a code over the finite field FPM.
Okay, thank you.
Thank you.
Yes, my question is, what computational tools were used to verify code parameters?
Repeats.
What computational tools were used to verify code parameters?
I use Magma. I use Magma.
Okay.
Yeah, I use Magma, but there is some problems. But because for the great values of n, the program don't work.
And what is the decoding complexity of the resulting codes?
The complexity, I don't calculate the complexity of algorithm, but for the great values of n, I can't give some results if for some values for great values of n.
And last question is, what is the strongest limitation of your approach?
Repeat.
What is the strongest limitation of your approach?
For my work, as
Limitation.
I use CS as constriction. This constriction technique enables the systemic derivation of families of quantum aerocorrector rather than just of use specific codes with the predetermined parameters. For example, in the future, we can use CS as constriction without use DL continual code, because we have all information about this ring.
Okay. Okay. Thank you.
Thank you.
Thank you.
Thank you so much, Mohammed, for your engaging and
Thanks for your coordination, everything flowed simply and was inspiring. Thank you for your dedication and exceptional work.
Yes. Thank you so much. Now, we'd like to move forward with our next presenter, who would be Aileen Kaur. I would like to invite you to present your paper on the limits of conditional volatility, assessing cryptocurrency value at risk under EWMA and IGARCH models. You may start your presentation by sharing your screen.
Can someone really quickly confirm that my screen is audible?
Yes, your screen is visible.
Your screen is visible? Yeah. Oh, sorry. Yeah. Good morning, good afternoon, and evening, based off all your time zones. My name is Aileen Kaur. I'm based in the United States of America. I'm a graduate alumni from the University of Florida, and I'm based in Bay Area, California. So let's go Bay Area. Today, I'll be presenting a dad joke. Just kidding. I'm presenting the limits of conditional volatility, where we assess value at risk for high beta altcoins, specifically XRP, Solana, and Cardano under EWMA and IGARCH frameworks. So this is like a layout of how this talk is going to look like. This talk will cover why traditional models like geometric Brownian motion failed in crypto space, and then we will deep dive into the mathematical transition from static to dynamic volatility, and we will be headbutting our three competing models in this as a part of this research work. So let's take a minute to talk about our paper one. So this paper is a part of a comprehensive series. We published our paper one very recently. So I just want to go over some baselines that will be essential when we go over this research. So our benchmark used geometric Brownian motion, which is a foundational model in finance, and it assumes homoscedasticity, meaning volatility is constant. So while geometric Brownian motion provided a critical starting point, the results were not ideal, and then that showed a 80.67% loss probability before 100, like in front of 100K initial wealth investment in my stock portfolio. So this essentially meant that our GBM model was blind to heavy tails and volatility clustering and assumes that yesterday's crash has no memory today. So we wanted to like fix this particular gap from our paper one and then address this in this framework. So we want to do a paradigm shift from static to dynamic volatility and then focus on heteroscedasticity. So the fact that variance changes over time is our primary premise of this work. And then in crypto, large shocks tend to follow larger shocks. And this is not an assumption, but a historical covariance structure that we wanted to establish using our research to move beyond static models. And to do that, we essentially considered three levers of volatility. One is alpha, that is the reaction parameter that in which the model reacts to a sudden price shock. And then beta, that's the persistent parameter that measures how much of yesterday's volatility shocks affects my today's model. And then kappa, that represents the mean reversion. Think of it as an elastic band that's like trying to pull back volatility to a long running average. So in our model, we tested this in the premise of altcoin cryptocurrencies to understand if this band can actually even exist. Or be even used for traditional finance for cryptocurrencies, particularly altcoins. So we use exponentially weighted moving average in our model. So this is one of our foundational concepts on which we built our work using a decay factor that's represented by lambda. So in our study, we tested our model across a varied range of lambda values, but then documented the result on industry standard that was 0.94. That essentially means that we give 94% importance to the entire history of the asset and then only 6% weight to the most recent price change. Why 6%? It's a smoothing mechanism that ensures the model doesn't overreact to single news headline, but still acknowledges that today's price matters more than price from 3 years ago. So this gives the model a memory that naturally creates and captures volatility clustering. So this equation is simply put the sum of a small slice of today's return squared with a huge slice of yesterday's variance. In ICICT models, the sum of our reaction parameter alpha and our persistence parameter beta equals 1. This is integrated GARCH or generalized autoregressive conditional heteroscedasticity. So mathematically, this means the memory of a shock never completely fades away. Standard GARCH 1,1 is stationary, meaning it assumes that volatility eventually returns to a log running mean. However, altcoins exhibit regime-like behavior. Their variance accumulates rather than decays. So therefore, we adopted IGARCH, where we assumed that alpha and beta equal 1. So we also rejected student copula to capture tail dependencies, particularly because of not yielding meaningful improvements over simpler univariate conditional variance specifications that we already established in our paper 1. So we tested three specific variations. This is exactly the summary of the three models of our work. The first is the persistent model that assumes shocks are permanent and carry forward. They are also pure IGARCH and EWMA with infinite persistence. The second, anchor model, adds a mean reversion term, and then IGARCH with explicit mean reversion tests if volatility actually anchors to a mean. It assumes that no matter how crazy the market gets, volatility will eventually settle back to a normal level. And then model 3, the sensitivity model, that's an asymmetric approach. So it tests if the bad news in the industry creates more volatility than good news. So in traditional stocks, it does. We are testing that if it holds for our altcoin portfolio. So we use log returns for our modeling, additive, and then conditional variance and correlation metrics, allowing us to model XRP, Solana, and Cardano crash together during stress. So our final metric, value at risk, fifth percentile, represents a reasonable worst case scenario, telling us the minimum loss we should expect in the 5% worst trading days for a $100,000 initial investment. So we fed these dynamic volatility estimates in a 10,000 price path Monte Carlo simulation. And crucially, we used Cholesky decomposition to preserve the high positive correlation between these three crypto assets during market stress. And this ensured the simulation reflects realistic cross-asset dependence, since we built our covariance metrics using historical data. So our results tell a very interesting story. Model 2, the optimist, assumed that the mean reversion, it pulled the risk down artificially, underestimating the danger by 50%. And this was our interpretation from the results. So Model 3, it over-penalized the portfolio, creating a risk estimate that was too high to be useful for capital efficiency. And then Model 1, the closest to realist, this provided a more robust result. While it strongly captured the regime risk of altcoins, we don't consider it our final model yet. It captures the spirit of the risk, but the weight distribution suggests that there is still room to refine and like how it handles a massive like weight distribution in multi-asset portfolios. But the results are stark. This model provided the value at risk at nearly $126,000, which is a 688% increase from the failed geometric Brownian motion benchmark that we established in our first paper. So this was one of our significant improvements through this work. So looking at the dashboard, we see that Model 2 had the lowest loss probability, and it did not completely capture altcoin movement, but it had a better weight distribution for the asset class. So we observed for altcoins, mean reversion is not a safe assumption because it forces variance to normalize even during structural regime shifts. So yeah, that was one thing that we wanted to note for this research. And our findings allow us to refine traditional financial theories for altcoin class. So for mean reversion, that is our Model 3, the altcoin volatility tends to accumulate rather than anchor. So it behaves like a snowball rather than a pendulum. And then for the leverage effect, that's our Model 2, altcoins don't have a debt to equity ratios that cause bad news to hit harder. They react to sentiment equally in both directions. And I want to make a note to that on this particular remark. This was one of our concerns highlighted by the chairs from the paper one that we presented in December this last year. So they asked us to evaluate the sentiment of our crypto model based on the industry's moving sentiment. So we particularly did that gap in our first work to fill that in through this research work. And then regarding infinite persistence, we support that IGARCH, integrated GARCH structure as like the most currently accurate. And this is because of also having positive results, but we also acknowledge its inherent limitations in weight distribution, which we aim to solve in our future work. So a key takeaway is that stationarity is fundamentally flawed for altcoin risk assessment. Infinite persistence can be structurally apropos for altcoins because these assets are in constant state of price discovery. So sigma t, that's like the current volatility, should carry all historical shock information forward. When we applied this to our portfolio, the model resulted in a 100% allocation to Sol. This is not a model flaw. This isn't just that because Sol went up, it's because Solana provided the highest Sharpe ratio, meaning it offered the best return for every unit of accurately priced risk. So this work offers a novel contribution to the study of non-stationary heteroscedasticity in emerging digital assets, particularly the altcoin class. By validating IGARCH constraint in a correlated Monte Carlo framework, we provide a mathematical bridge between traditional risk management and unique volatility regimes for decentralized finance. So while IGARCH is robust, these are some of the limitations of our work. It is a continuous model. It struggles to account for black swan, price caps, or flash crashes. This limitation led us to believe that we will be building our next work towards step diffusion models to account for discrete stochastic jumps in price. And furthermore, we will be exploring Hawkey's process to build from persistence modeling towards contagion to modeling contagion across altcoin portfolios, exhibiting how one shock can trigger another across the DeFi ecosystem. So as we conclude, I want to address the scientific why behind this bibliography. So while the literature on cryptocurrency is expanding, it suffers from a systemic large cap bias. Most research from Nakamoto's foundational 2008 paper to recent work by Sozin focuses almost exclusively on Bitcoin and Ethereum. But as any practitioner knows, even as a blockchain developer, as a crypto researcher myself, these mainstream cryptos are not statistically representative of the entire industry. So I have used this literature survey to identify a critical deficiency, the altcoin gap. And then high beta altcoins like Zarbi, Solana, and Cardano constitute the bulk of trading volume outside the top two. So yeah, they do exhibit volatility characteristics, and there is no existing mainstream literature that captures this as of today. So the more uninformed the readers, investors are, the less trust they build in the crypto ecosystem. And that's the core tenet of this research work. So by citing these references, I'm establishing the diversified altcoin portfolio, the primitive mathematical assumption of traditional finance, like mean reversion and the leverage effect, that don't necessarily hold true. And this paper is a call for methodical re-engineering of the risk framework. We are providing the first clear evidence the non-stationary infinite persistence models are not just an alternative. They could be the next regulatory prerequisite for the rest of the crypto market. So thank you. I will conclude my presentation with a dad joke. Why should we not iron a four-leaf clover? Because one must not push their luck. I'm open to questions, if any. Thank you so much for being patient with me so far.
Okay, so my first question is, so have you examined higher moment dynamics like skewness, kurtosis, clustering?
Yes,
Hmm?
yes.
Okay. And what is the economic interpretation of infinite volatility persistence like alpha plus beta equal to 1 in crypto markets?
So the economical interpretation of this is that when there is a huge tail, like a tail flash crash, that is also called the dead cat bounce problem in the crypto markets. So as you're aware, stocks are like not super volatile when we compare them towards the crypto industry, and crypto assets tend to often not follow any structural pattern. So to capture this pattern, when we built our model on historical tail risks, it assumes an infinite persistence and then gives a higher outcome that can be inflated because of not being able to effectively capture the tail risk modeling. And this is something that we have also openly acknowledged as a part limitation, as also that's partly mitigated from what we did with paper one. So as a future work, that's why we want to consider jump diffusion models that will effectively capture these tail risk and flash crashes more closely than what currently conditional Garch is doing.
Okay, thank you.
Hi, Clean. Can you hear me?
Yes. Hi, Sachin.
It's nice presentation. I have
Thank
few
you.
basic questions like what data set and time frequency did you use for your proposed system, like the model you have
Yeah.
presented?
So for the data set, we used historical data from Yahoo Finance. So good news to us that we could just directly pull in the historical crypto data directly with their tickers. And then we use the time framework for 3 years, 3 to 5 years. So we trained it on both, but the paper documents 3 years, since we
Okay,
wanted to preserve the 5-year correlation for. So currently, this paper addresses three altcoin classes like Zarbi, Solana, and Cardano, right? So our future work wants to extend this to a larger crypto multi-asset class, and then we want to historically also go back in time to do the same work with jump diffusion models and effectively demonstrate the improvements for all the three papers together.
great. And how was the var 5%, like 0.05 was computed in the simulation?
We directly use the mathematical formula. It's available as a library.
Okay. And one last question, like, can the traditional financial risk models be applied to the crypto assets?
That's exactly what I really like your question. This is exactly what motivated this work, actually. That's why we started off with a very, very bad baseline, that's geometric Brownian motion, because it's foundational to all financial industry. And I also was very surprised as a researcher to not find any literature that actually addressed this limitation, that why geometric Brownian motion fails in the pretext of crypto volatility. So to answer your question, I do believe that we can apply financial fundamentals, but they have to be like highly catered to the volatility structure of crypto assets. And that also varies based off which type of crypto we are talking about. Is it a mainstream crypto like Bitcoin or Ethereum, or is it an altcoin class? So yeah, that's my response.
Okay, thank you.
Thank you so much, Akeen, for your presentation. It was very excellent.
Thank you so much, Pranjal. Thank you for leading the meeting. I really appreciate all of your question. It was really meaningful. And yeah, I thank you so much for patiently listening to me.
You're welcome. Next, I would like to move forward with our last participant, which would be Samuel Asampana Atara. I would like to invite you to present your presentation by sharing your screen. Samuel, are you there?
All right. Sorry, I was speaking. I thought the muting was from your end. Can you see my screen now?
Yes, we can see your screen.
Okay. All right. Thanks a lot for the opportunity. Good morning or afternoon or evening to everybody. My name is Samuel Atara Asampana. I'm speaking from the University of Ghana. I'm a senior lecturer at the Department of Physics. So I present to you some qualitative work that we did as part of EC co-sponsored project. We are not doing hard computing here. We are trying to see the depth to which AI, for that matter, digital technology, has sunk into the future workforce. So to say, the graduates that are being trained out by the higher education institutions. So without much ado, the presentation is as titled From Awareness to Practice, Industry Insights into Graduate Competencies for Digital and Sustainability in Digitalization, and Sustainability in Ghana. My presentation will take this format. I would do a brief introduction and a review what the twin transition activities there are in sub-Saharan Africa, where this study is centered. I would explain briefly the method used and summarize the key findings, and I would also make conclusions and recommendations on the implications of the study. Obviously, I would like to acknowledge everybody in the end. Very sorry. So before I go on to use terms that are not familiar or are not well introduced, I would like to explain first that the focus of the study, as I explained, was to explore the relation between the knowledge base of graduates that are trained by our higher education institutions and how relevant they are, or how much they meet industry expectation. And our study is focused on sustainability and green competence, so to say the twin transition. So when I say knowledge base here, I'm limiting it basically to knowledge on green and sustainability issues by the graduates. I'm also limiting it to digital skills of graduates as are relevant to industry and, for that matter, productivity. Eventually, we're trying to answer the question whether the higher education institutes, which I label here HEI, whether the whether the graduates that they are producing, are going to meet the emerging demands of the future workforce. So it ties with the objectives of the study. The overall objective here is to evaluate the extent to which graduates, acquire the necessary workforce required for the fourth industrial revolution. And it will also give us an indication as to what the higher education institutions are contributing or are doing in terms of producing the future workforce. Ultimately, the study seeks to address any limitations on the empirical research data that's available in this area, and we think that it's an emerging area. Hopefully, the study also identifies what shortfalls there are on the part of universities in producing the required workforce going forward. So let me introduce properly that, as I said, it's on green transition, or the twin transition, which is basically the transformation of society through digitalization and sustainability. Briefly speaking, this is how I would define twin transition. It basically combines digital and green functions to unlock benefits that are, beneficial to society and to productivity as well. The twin transition also leverages on technologies such as the AI and the Internet of Things. And what does it do with this? It helps to accelerate efforts or targets at achieving environmental and climate goals, so to say, in the end. So here I make a short overview of events that are all around sub-Saharan Africa. That's what I mean by SSA. We noticed that during our survey, we found that in Kenya, the government just banned outright the use of this single plastic, plastics that you use at once and then throw them away. That was absolutely banned. And the study shows that it reflected in 80% of enforcement in basically in the recycling target. We also noticed in South Africa that they launched a major circular economy project in link with the UNEP, which aimed to transition waste management from basically landfills to recycling. And this has been a very successful, albeit a continuing project. Here in Ghana, we have a large company called Zoom Lion Limited. What it does is it doesn't just limit waste by effectively managing and protecting the environment. It also contributes to the circular economy through recycling. Of course, it's a big employer, and it also helps in meeting the national public health targets. And so on and so on. We have here references on how, if you talk about digitalization or digital transformation, which I would use interchangeably here, the data also shows how digitalization has been beneficial and has positive impacts on the African economies. And so it is in the light of this that we are trying to check that how is the society itself through the learning institutions contributing to this transition. Let me tell briefly how we went about this study. It was purely qualitative exercise coming from the physics department. It was basically, and the deductions or the conclusions are purely deductive, not too much of coding that I have realized or witnessed so far in this conference. And so what we did was we contacted or selected 10 companies around town and around the country. And the criterion was that these companies must have graduate employees, a substantial number of graduate employees from whom we can assess their experience and qualities and skills. These companies must have been in existence for not less than 5 years, but I think in the end we got one that was 3 years and was very forthcoming. They had a rich graduate population and succeeding. So yeah, you will see in the data that as I already explained, the sampling technique was purposeful but wide in the sense that we had a varied, widespread, if you like, spectrum of participants. I have highlighted here on the right-hand side how varied the participants. You have it later here. Yeah, I've highlighted over here. They were coming from banking sector, from the tech sector. They were coming from event planning, private organizations, the NGOs. Skills are sunk into their graduate employees. What I have here also is the number of years for which they have been operating. This ones here just refer. We basically say distinct identifier to the participant. So down the line, if we refer to participant 1 or 2, it is either a banker or it is a tech private company and so on. But this is basically the sample, the companies that were sampled and then their details. Moving forward, upon collecting the data, which was basically qualitative basically in the sense that we called them up, had a discussion with them, gave some questionnaire to write out. So if a company answers no, we have to go through this model to digitize eventually all the data from no into 0 and yes into 1s, and also the grading, the scale on which they rated each subject. All that digitalization and analysis, we use the Brown and Clark's model, pretty old model, but for social sciences, it has worked to help us. Okay, so the questionnaire or the questions in teasing out green skills, we try to find out what were the skills of graduates at entry level into the industries. We try to find out what the employers, or to what extent the employers are satisfied about these graduates. On the area of digital skills, we try to find out what are critical digital skills that are deemed essential for entering into the industry, how prepared graduates were in entering in terms of their digital competencies, how they were also prepared to take up roles. Do not want to spend all the time on this sample, but let me come forward with a summary of the findings. The findings we first sought out in the questionnaire to find out how much did they meet employer expectations. So what we found out was that some key attributes, and I say again here, attributes were the knowledge based on the sustainability and digital skills. How did the employers rate this graduate employees in that light? Let me fast forward and then tell what they said. We found out that employees they valued proactiveness and smart decision making from employees. They valued clear communication and customer service orientation. They valued willingness to learn or unlearn bad habits once they enter the industry. Adaptability to work and in different areas. Basic proficiency in digital tools, office tools, as well as industry-specific tools. These were some of the expectations. And how did they rate them? I show you here very few samples of how some industries rated them. They say that graduates generally possess basic knowledge, which is considered sufficient just for entry level, with a view to them being trained going ahead. Participant 9 stated that graduates' readiness for industry is just about average. Okay, and here are a lot more from the various participants. If you put all of them together, you find out that the expectations were varied. I'll give you an example. If you work in the tech sector, if your industry is into the tech business, you valued, you look for graduates with higher tech and awareness and green practices. And so company did not even know much about the importance of sustainable practices like recycling and all this. So this just summarizes what we got from the participants. And the summary is that each industry valued the graph. That, okay, currently the world is changing. Your readiness means that you think that all graduates could use their own in-house specific tools. For instance, if you were to use Anaconda to analyze data in a very efficient manner, graduates have a long or kind of learning curve to meet their expectations. And here comes another participant. Overall, let me go forward to say that we found some gaps. And the gaps that
Sorry to
we
interrupt,
discovered.
Samuel, but your time is up. You'll have to conclude your presentation.
Thank you very much, Madam. Let me go on to say that we have some recommendations, which are basically like requiring review of university and educational institutions curricula and partnership with the industries to refine the graduate workforce. Thank you very much for the opportunity. Thank you. Having thanked you, I wanted to introduce or acknowledge the team and then all, of course, this conference organizers too, who have given us the chance to showcase our work. This work was sponsored by the Erasmus project and the University of Ghana. Thank you. And this is the full team that was included. Thank you very much.
Yes. Thank you. Thank you, sir. My quick question is like, how do digital competencies differ from digital literacy?
Oh, well, digital competency would refer to one's ability to use analytics, like production specific tools. So for instance, I gave an example of Microsoft Office tool. I gave an example of analytical tool like, Power BI, things like that are skills. Those are competencies that industry use. Literacy, it's just about literacy. Literacy is awareness to be able to get around in a computer in general, and that's not what we were looking for.
Okay, and how is sustainability competency conceptualized in your study, like environmental, economic, or socio-technical?
Let me understand your question, madam, please.
Sustainability competency. So the sustainability, when you say sustainability, so how it is conceptualized in your study, environmental, economic, or socio-technical, how it is that sustainability?
Largely environmental, largely environmental and environmental sensitive, and those habits that contribute to hitting the sustainability goals in terms of bringing down. Basically, talk about recycling, the circular economy, talk about basic awareness of the effect of digitalization on bringing down global emissions. This we found to be quite important, talking about graduate employees, but yet a little bit minimal. Most people could not tell the link between using digital tools to make work that could be done with less resources, like printing or things like this.
Okay, and the last question is, what structural challenges in Ghana's education system affect competency development?
Thank you very much once again. So I'm sorry, I probably delved in other things and did not have enough time to display what we found. But what we found out was that it appears that students do not have the chance to or the opportunities to interact with industry and learn the practical skills to supplement the real theory that they get from the universities. It appears that the University of Ghana as a case study, it will appear that there is not enough exposure of students to practical stuff. And yeah, also the curricula does not explicitly require this practical element in some courses. So we found out that this was playing out. They get into the industry knowing what there is, but a little bit quite new to how it is or it is supposed to be done.
Yes,
And that reflects in our recommendations, where we said that recommendations, we recommended that there's a more stronger collaboration between industry and university. We also proposed that there be a curricular review to require these things explicitly, internships of students in industry to inculcate or let them grow these skills before they hit the market. Thank you.
Thank you. Thank you.
Hello, Samuel. Can you hear me?
Yes, please. Thank you.
So continuing to the questions, previous questions, according to your data, what are the main reasons of the graduate failing? Like what you identify that why the graduates are failing? What was the key reasons you identified?
Yeah, so thank you again for the question. So basically what we found out was that these graduates hit the market with average skills than expected by the employees because they do not have this exposure to practical, hands-on practice about these very things before while they were at school. That's one thing, and that's what we attribute to. Could it be possible that, for instance, if you have a class on accounting, yeah, rather than teach students all about what it's about, leave them time in a lab to use Microsoft Excel to practice. So by the time they get into their industry, or they are familiar with how to go around this and how to do it quicker than even the aging staff. But these ones, it looks like they are not so exposed during their active study time. And this was one reason why we felt that our employees thought that their expectation was not met completely. Thank you.
So do your results or study imply any modification or updation in the existing courses?
We thought that a regular review of the curricula would help. We also thought that industry is the best person or partner that knows what they require. So industry university partnership in terms of events, fora, consultations as the direction of training would help. This is what we at large discussed about. I'm trying to use the slides to answer the questions each time they come up, but we did find very, very intriguing facts underlying this knowledge and industry relation.
So are you working on any practical implementation or anything like that?
Oh, yes. What we do at the moment, well, the project is in phases. A dissemination is particularly bringing this data to university managements all around. We are targeting the International University of Management in Namibia. We are targeting the one in Winneba, also in Ghana. And then there is the partners in Finland and Slovakia. The target is so a component of the project is about dissemination. And that part It's about bringing these facts to the table, head to head with university management and whoever matters, so that these things can be resolved as time goes. It wouldn't be one day, but if the drums start beating, then people in position start to care. That's the practical part we are looking at.
Okay, sounds good. Thank you so much.
Thanks a lot, sir.
Thank you so much, Samuel, for the time and effort that you have put into this amazing presentation.
Thank you very much. Indeed, I'm glad that we were able to be contained, because it appears that the organizers did not find a slot for us, although we registered so early. And I got told just this afternoon to join. So I'm glad that you find space for us. And thank you very much once again. Thanks to everybody.
Thank you to you too.
All right, cheers. I will share myself.
Now, I would like to conclude this session by sincerely thanking our authors for their excellent presentations and valuable contributions to this session, and all our participants for being a part of this international conference. I hope this session was informative and enriching for everyone. All the presenters will receive their digital certificates via email within 2 working days. Publication will be live within 7 to 8 months. Kindly cooperate with the ICICT 2026 team. On behalf of the entire team, thank you for your continued support through the 11th edition and all the previous editions. We look forward to welcoming you again for the 12th edition in 2027. Now, as a token of appreciation for our session chair, I would like to present these certificates on behalf of Team ICICT 2026 and Global Knowledge Research Foundation and partners. I would now like to invite Dr. Sachin Jain to kindly deliver the closing remarks.
Thank you, Pranjal. Can you hear me?
Yes, sir, you're audible.
Yeah, thank you. As we conclude this session, I would like to express my heartfelt gratitude to each of you for your active participation, presentation, insightful contributions, and engaging discussions. I also want to acknowledge the hard work and dedication of the conference organizers, sponsors, and of course the volunteers. Thank you all, and I wish you all continued success in your future endeavors. All the best, and thank you very much.
Thank you so much, sir. Now, I would like to invite Sangeeta Kurundkar to deliver the closing remarks. Ma'am, you're muted.
Okay, am I audible? Yes, I would like to extend my sincere appreciation to all our presenters today for their thought-provoking contributions. And the quality of research shared today reflects actually the depth of innovation and the strong commitment. And the presentations also highlighted the significant advancements in their respective fields, and also the discussions and the intellectual exchange and the questionnaire, whatever interaction we had, it truly enriched the session and demonstrated the collaborative spirit. And actually, this is what the international conferences aimed to foster, basically. So I would also like to thank the organizing committee for their meticulous planning and seamless coordination, which ensured the smooth conduct of this session. So it has been an honor to serve as a session chair and to witness such diverse perspectives and high quality research work. Okay, so thank you so much. Thank you for today.
Thank you
Thank
so
you,
much.
Pranjal. Yes, thank you, Pranjal.
I would extend my sincere gratitude to our session chair for chairing the session with great energy and for their valuable presence and guidance throughout. Now, I would kindly request all of you to switch on your cameras for a quick snapshot of the virtual conference for valuable memories to display on the conference website. Everybody, please turn on their videos. I'll be taking the screenshot now. Everybody smile. Thank you, everybody, for being present. Stay safe, take care. I'll conclude the session for today.
Yes, thank you.
Thank you and bye.
Yes,
Thank
bye.
you, everyone.